Assalamualaikum warahmatullahi wabarakatuh. I'm Nihida binti Maizli. Today I want to present about type of sample that we use by analyze with using UV spectrophotometer. That is paracetamol. Paracetamol generally a simple calorimetry enzyme based on method used for assay of paracetamol. Paracetamol also can be assayed by quantitative estimation using UV spectrophotometer. Paracetamol consists of a benzene ring core substituted by one hydroxy group and the nitrogen atom of an amide group. Today I want to explain about the technique used for analyze the sample, which is UV spectrometer. The sample was paracetamol, and then the paracetamol which used to analyze by UV spectrophotometer. First, let's go. The UV spectrophotometer was put at 0 by running a baseline between 200 until 400 nanometer using 0.1 molar natrium hydroxide solution as a blank. The absorbance of each sample was determined at 257 nanometer by putting small amount of the sample into a cuvette, and the cuvette was put into the machine. The same procedure was repeated for the standard using 100 mg of the powered standard. And absorbance determined which was used to calculate the percentage content in milligram of paracetamol from each brand. The concentration of each sample was also determined using Beer-Lambert law.
My name is Nur Ain Atira binti Zamri and my matric number is 1022. I want to talk about preparation of sample using paracetamol. So the procedure is we have to prepare 120 ml of distilled water, and then we have to weigh out 10 mg of paracetamol and then transfer it into a volumetric flask, 100 ml volumetric flask, and then dilute the paracetamol with distilled water and sonicate the standard solution. After we sonicate the standard solution, we have to carry out a series of dilution, which is 1.0 gram per liter, 0.025 gram per liter and 0.05 gram per liter. For 0.1 gram per liter, we have to take 10 ml from stock solution, which is the paracetamol with 100 ml distilled water. And then, for the 0.025 gram per liter, we have to take 2.5 stock solution and 2.5 distilled water. And for the 0.05 gram per liter, we have to put 5 ml stock solution and 5 ml distilled water. The overall volume is 10 ml. So we have to make 10 ml of each dilution and use distilled water as a solvent to make the dilution.
So usually there are few methods of analysis that we can consider during the application of UV spectrophotometer. So it is involved the measuring amount of radiation or ultraviolet light that absorbed by a substance or sample in a solution. And then the analytical procedure is referring to the way performing of the analysis, and it is usually described in the detailed step if it is necessary to perform any analytical test. And may include but not limited to the sample, the reference standard and the reagent preparation, the use of the apparatus, generation of the calibrated curve, and the use of the formula, which is Beers-Lambert law for the calculation of the sample. So there are a few methods that can be validated during the method of analysis. The first is identification step. Next, we have a quantitative test for impurities content. We have a limit test for the control impurities. And the last is we have a quantitative test of active moiety in the sample of drug substance or drug product or another selected component in the drug product. There are also some suitable parameters that should be considered during carry out the spectrophotometer analysis. So the first, there are several scan parameters that either directly or indirectly determine whether they take a measure of spectrum of quality of the spectrum. So this parameter including a wavelength range, a scan speed, the slit of wave, and the data point interval. pH and temperature also affect the absorbance, so this is also the important parameters, and the sample concentration. Okay, so as the concentration in the sample solution is increased, the absorbance reading of light intensity also will increase respectively. And then the solvent carry for the sample the solvent carry for the sample and the sample cell, which is cuvette length that used for this spectrophotometer analysis is also one of the important parameters. And the last parameters such as diluent, buffer concentration, and other chromatographic condition is also need to be considered as a suitable parameter for this spectrophotometer application.
Hi, Ms. Irma. I'm Tivashni Sugumaran from DPT 5A, and today I'm going to be explaining about the expected and possible results of using UV spectrophotometer for you. So the sample we used was paracetamol, and that was prepared in different concentration. So the purpose was to identify the relationship between the absorbance and the concentration of that specific material. In this case, we used paracetamol. So first, we need to determine an ideal wavelength for paracetamol in nanometer. So to simply say, we've got to find its own unique Amax value. Amax value is the maximum absorption value in nanometer. It's the wavelength where the paracetamol will absorb more light. So it's a specific wavelength. So hence the selection of the first hence the selection of the wavelength is first performed, and then the quantification of paracetamol using spectrophotometer may be carried out by preparing solution in transparent solution. For example, distilled water. In this case, we use distilled water for this experiment. And then we measure its absorbance at different wavelengths, and finally selecting the wavelength with the maximum absorption as Amax. So later, when the Amax is identified, the UV spectrophotometer is set to the identified Amax value, and then different concentrations of paracetamol that we prepared previously will be measured for its absorbance. So the higher absorption has the higher concentration as per stated in the Beers law. So this law states that the absorption of light is directly proportional to both the concentration of the absorbing medium and the thickness of the medium in the light path. So the more the absorbance, the more the concentration. That's the conclusion. Thank you.
My name is Kumuda Aramugam and last 4 digit of my metric number is 1003. So now I'm going to tell how this ultraviolet visible or UV vis spectrophotometer can improve the quality of health or environment. First, let's look at the environment. Ultraviolet visible spectrophotometer is widely used in environment, especially in water safety analysis. Ultraviolet visible spectroscopy utilizes the measurement of light absorption to quantify bacterial concentration levels in water samples accurately. This process is immediate, portable, cost-effective, making it a leading choice in analytical instrumentation for water safety analysis. Other than that, UV vis spectroscopy also used to differentiate between free chlorine and combined chlorine residuals. Those who maintain water sources often add chlorine due to its disinfecting purposes. A small portion of residual chlorine results from this process. So water must be accurately monitored to ensure it is safe for human consumption. There are two main forms of residual chlorine exist, commonly referred to as free chlorine or combined chlorine residuals. UV vis spectroscopy offers an effective method for differentiating between these two. This identification is important because free residual chlorine is often considered a more effective disinfectant and can be used more effectively when properly detected in drinking water. Fluoride is another common additive to our drinking water. UV vis spectroscopy can also be used to quantify levels of this element for both safety and effectiveness, and also provide an easy, non-destructive, chemical-free and effective method of detection. Precise quantification and data can alert environmental specialists to access level of these additives in our drinking water. UV vis spectrometry is also used as a quick, first non-specific screening of unwanted compounds in water. By measuring the color of process during the production of drinking water, we can determine if there are unwanted compounds in the water. A UV vis spectrometer is much more sensitive for the color than the human eye. Especially in the UV part of the spectrum, it is helpful to perform a measurement since our eye do not see UV light. Apart from this, ultraviolet visible spectrophotometer is also used in health or hospital fields. It is mainly used for determination of the reaction rate of a biochemical reaction. For an example, enzymatic reduction from NAD to NADH2.